So I want to bring in how Q or K applies to a reaction when you look at it like this, because so far what you've seen is we grab this part and we split it up from this part and this part. But you want to remember it's actually one reaction. So this guy, as he's getting 3 electrons, he's not just getting them from anywhere. It's actually getting 6 electrons because it's twice of them. It's not just coming from anywhere. Those electrons are actually coming from this one. And that's why this one is becoming 2+. So it's a both and. You can't have one without the other. It's a complete, it has to be this way. You have to have both parts or nothing happens. So if you remember phasing wise, when you've seen all of this, we keep talking about solid pieces of metal, and that's actually what this is. This is a solid piece of metal, and people will hook an electrode to it, a little chunk of it. And same with the aluminum. It's a little solid piece of metal. And then when we have charges, remember, something's ionic and dissolved in water, it's going to be called AQ, and this part will be AQ. And if it bothers you to be seeing it like this, because you're like, but isn't that part of another reaction? Okay, yes, you're right, it is. Let's just say it's like aluminum chloride, okay? So aluminum chloride and cadmium chloride. So the idea is the chlorine ion atoms don't actually participate in the reaction. If you remember the word spectator ions, they're not actually a part, they're just there for charge balance. So we could have put it in and it wouldn't have changed anything in how we write the electrons for the reaction. So to simplify things, we often leave it out, but I know that can sometimes bother people. So if you want to put in the chlorines here, it's fine, and you'll see that they all balance and everything. And that is proper. Like, it is proper to not show something as an ions per se. But when we're looking at the reactions, you need to also put phases in and make sure to understand that that will break apart. All right, so when we write Q or K, remember that it's products of reactants, and you're probably so sick of this, right? But remember that they are raised to their coefficients, and notice that a lot of these have coefficients. Remember that this value goes in brackets, which represents molarity, and then also remember that only certain phases can go in this. Aqueous can go in, and gases can go in. Things that can't go in are liquids, because water is listed as liquid, and solids, because solids aren't dissolved in water, and therefore they can't be solutions. So if we wanted to write the K for this, and I keep saying or Q, and the reason I keep saying that is because when we're talking about electrochemistry, most of the time we're not talking about a reaction that's reached equilibrium. And the reason for that is once you've reached equilibrium, if you're a battery, what that means is that all of the electrons that are going to go to the other side have done it, and they're done moving, and they're not going to move anymore because they've reached equilibrium. And so most of the time for batteries, you don't want K because your battery is going to be dead. Now you can charge it up again, and then it'll go backwards, and then it'll keep going forwards because it's reversible. Well, some of them won't. It depends on, I guess you could say, the material, but we can think of it as a reversible process. So we like to talk about things in terms of Q, like hey, we just got a brand new set of batteries out of their package, and they're super awesome, and they have a lot of potential, and they're going to go. So Q is like before we reach equilibrium. Equilibrium in terms of batteries is bad. So remember, we only include AQs, right? So the Q for this would be that, notice it's raised to the third because I have a 3 there, and then it would be that, and notice this is going to be raised to the second because I have a 2 there. So hopefully that helps.